This is the second video in Unit 2, and this one is on box plots and how to construct them. This should be on the reverse side of the notes you've already taken on means and medians. Okay, first we'll discuss some of the advantages of why we would want to use box plots as a distribution of our data. First of all, they're very easy to construct, and that makes them helpful to us. And there's a easy, convenient way for us to determine what are outliers and what are not, and we'll discuss that later in this lesson video. The construction is also not subjective, meaning that two different people could make histograms using the same data and come up with histograms that look slightly different. And that's not the case with box plots. Everyone should come up with a box plot that is the same. We can use them with medium or large sizes of data, as long as we have 10 or more observations. That's what we would use, and they're useful when we're trying to compare two different sets of data together. There are a couple of disadvantages to using box plots. Like histograms, they do not retain individual observations, and so we can't go and pinpoint each data value individually as we could in a stem and leaf plot or a dot plot. And we can't use them with small data sets, anything of less than 10 data values. Now, to construct a box plot, we first are going to find the 5-number summary, which we mentioned in class last week. Remember, the 5-number summary is the minimum value of our data, quartile 1, which is also the 25th percentile, the median, also the 50th percentile, quartile 3, the 75th percentile, and our maximum data value. And what we'll do with that is we'll start off with our box plot, and I'm going to kind of draw on here where I have some space, hopefully. Alright, I made me some space down here at the bottom. I'm going to draw a box from quartile 1 to quartile 3. So we find those values, and we just make a rectangle of those values. It's not a very good one. Alright, that's a little bit better. So this would be quartile 1, this would be quartile 3, whatever those values might be, and we'd have a scale underneath to show. And we're going to be constructing some of these in class together as well. And then we want to draw the median as a center line in the box. Now, the median does not have to be exactly in the middle of quartile 1 and quartile 3. It depends on the data values that you have. And so it might be to the left. If it is, like if I drew it over here, that would be something that would be rightly skewed. If it's more to the right of the box, that would be data that's more left skewed. If it's exactly in the center, we would have data that is symmetrical. But it does not have to fall in the center. It's just a line in the middle of that box, or within that box, excuse me. And then whiskers are extended to the minimum and maximum values of our data, as long as these are not outliers. And we're going to talk about how to determine what are outliers and what are not, because we're going to be using modified box plots instead of just regular box plots. So we do want to make sure that our minimum and maximum values are not outliers, and that's what we're going to be discussing next. So it would end up looking something maybe like this. So I said on modified box plots we'll display those outliers for us, and we're going to have some fences that mark off those outliers. Those are going to be dotted lines. And whiskers will extend to the largest and the smallest data value inside that fence. So the picture might look something like this. So my picture here, I have my quartile 1, quartile 2, quartile 3. This would represent my minimum value, and this right side would represent my maximum value. And these two dotted lines represent my fences that would mark off any outliers. So if I did in fact have an outlier would be represented by just a single dot on the outside of that fence. So again, from quartile 1 to quartile 3, is your inner quartile range. And remember, we calculate that using Q3 minus Q1, and we talked about that last week, so we should remember how to do that. And the inner quartile range represents the middle 50% of your data. Again, the inner quartile range represents the middle 50% of your data. And now here we see how we will determine what is an outlier and what is not. So to determine an outlier to the left of our data set, we take the quartile 1 value and subtract off 1.5 times the IQR. So let's say we had a quartile 1 value of 10 and we had a quartile 3 value of 30. If I wanted to find where this dotted line would fall, I would take the 10 and subtract off 1.5 times 20, because 30 minus 10 is 20. So performing that calculation there, 10 minus 1.5 times my inner quartile range of 20, I get a value of negative 20. And so that means if I had my list of data, if I had one that fell lower than negative 20, like negative 21, negative 22, and so on, then I would represent it with a dot on the outside of this fence. And in the same fashion, I'm going to find the other side, the right-hand side fence, using quartile 3 plus 1.5 times the IQR. So performing that calculation to get this fence line, 30 plus 1.5 times 20, I get 60. So any value greater than 60 would be represented with a dot, such as this one over here, as an outlier. And then my whiskers for my my whiskers for my box plot would extend to the greatest value that is not that outlier, and it would extend to the greatest value that is not an outlier, the least value that's not an outlier on this side. So here's a picture of what that might look like. So let's say that we had a outlier data value of 75. So then in my next highest value was, because our line was 60, so let's say our next highest value was 58. So instead of this whisker extending to the maximum value of 75, it would extend to the value that is next to that 58. And that concludes tonight's video. Tomorrow in class we will take care of the example problems of creating box plots and then comparing them and also describing them. But we will be describing these box plots using our CUSS acronym to discuss the center, anything unusual, the shape, and the spread. Please bring these notes with you to class tomorrow.